This is the video for section 4.4 notes, slide number 28. All right, so it says find the intervals over which f is increasing and decreasing, local extreme values, intervals over which f is concave up, concave down, inflection points, and provide a sketch of the graph. All right, so whole bunch of stuff happening here. All right, so obviously increasing and decreasing, we need to find whether f prime is positive or f prime is negative, right, to talk about increasing and decreasing. All right. Local extreme values, remember that's where we talk about whether f prime changes from positive to negative or negative to positive to talk about local max and min. All right. Intervals over which f is concave up, concave down. Remember, concave down means f double prime is less than 0. Concave up means f double prime is greater than 0. All right. Inflection points, remember that's when the concavity changes from f double prime positive or negative to f double prime negative or positive. And then sketch a graph, that's where we need to do the double sine analysis to determine the shape of the curve. All right, so that means we need to find f prime of x. All right, so f prime would be 3 plus derivative of sine is cosine of 6x times the derivative of 6x, which is 6. All right, so that's f prime. All right, and then we want to find f double prime as well. So f double prime of x is derivative of 3 is 0, derivative of 6 cosine of 6x would be 6 times the derivative of cosine, which is negative sine of 6x times another 6. And so we get negative 36 sine of 6x. All right. And so now what we want to do is we want to set each of these equal to 0. So 3 plus 6 cosine of 6x equals 0. All right, and so I subtract 3, divide by 6. So I get negative 3 over 6, or negative 1/2 equals cosine of 6x. All right, and so now we want to figure out when is cosine equal to negative 1/2. So if we're thinking in terms of the unit circle, we know cosine is negative 1/2 in quadrants 2 and 3. Right, and so that would be where 6x, remember 6x is the angle in here. So 6x is equal to, well, whatever that is there. So that would be 2 pi over 3, right? So 2 pi over 3, but then plus 2 pi n, right? Now, I know we're restricted from 0 to 0 to pi over 2, but we're going to divide by 6 here, so that may change. So we're going to divide by 6, all right? And so we get that x would be equal to 2 pi over 18, right? Plus 2 pi n. So if I divide here, I get pi over 3n, right? All right. And now we also have that 6x would be equal to, if we go into quadrant 4, that would be 4 pi over 3 plus 2 pi n. And so then we're going to divide this by 6 as well. And so I get that x would equal 4 pi over 18, right? 4 pi over 18, all right, plus pi over 3n. Now, 2 pi over 18, of course, that is pi over 9, right? Plus pi over 3n. And then this one would be 4 pi over 18, so divisible by 2, 2 pi over 9 plus pi over 3n. All right, and so now we need to realize what our domain is, 0 to pi over 2. So pi over 9, of course, is between 0 and pi over 2. But then if I add, let's see, pi over 3, that would be like 3 pi, sorry, you were adding 3 pi over 9. And so 1 pi over 9 plus 3 pi over 9 is 4 pi over 9, which is still between 0 and pi over 2. All right, and then over here we have 2 pi over 9. So obviously that is included, right? But then if I add 3 pi over 9 to 2 pi over 9, that's 5 pi over 9, which is greater than half of pi. So we have these three values that would go on our number line. All right, so we'll put those on our number line in just a moment. All right, next we want to set f double prime equal to 0 so we can fill out our number line as well. All right, so we can divide by negative 36, so obviously that goes away, so we just get that 0 equals the sine of 6 pi. All right, and so, or sorry, 6x. All right, so when is sine equal to 0, right? So sine is equal to 0 at 0. So 0, pi, 2 pi, 3 pi. So that would be just 0 plus pi n, or pi n. And so we can divide by 6, and we get that x is equal to pi over 6n. So that means that x is going to be pi over 6, right? And then if I add another pi over 6 there, we get 2 pi over 6, which is pi over 3, and we get 3 pi over 6, which is pi over 2, which is one of our endpoints. And so then we would be done, right? And also, of course, 0, right, which is our other endpoint. So we want to start with our endpoints on the number line. 0, pi over 2. All right, then we need to put these numbers, pi over 9, right? So pi over 9 goes first. All right, then we have pi over 6. Then we have pi over 3, or 4 pi over 9. Remember, pi over 3 is 3 pi over 9, and 4 pi over 9 would be after that, but we also have 2 pi over 9, so that has to occur on there as well. So I apologize. I want to make sure I have pi over 9 and 2 pi over 9. Then we have pi over 3, which is 3 pi over 9. Then we have pi uh, I apologize once again. All right, 2 pi over 9 is 4 pi over 18. All right, and so we should have pi over 6 here. I apologize. So pi over 9, pi over 6, 2 pi over 9. All right, then we have pi over 3, and then we have 4 pi over 9. All right, so I hope that is right. All right, remember, pi over 9 would be 2 pi over 18. Pi over 6 would be 3 pi over 18. 2 pi over 9 is 4 pi over 18. Pi over 3, that would be 6 pi over 18. And this would be 8 pi over 18, right? Like, so it looks like we're in the appropriate order. So I apologize for that. All right, now we want to do our sign analysis of f prime and then our sign analysis of f double prime. All right, so sign analysis of f prime, I'm going to put on top here. So I just have 3 plus 6 cosine of 6x, right? That's my only factor. So 3 plus 6 cosine of 6x. All right, and then on the bottom, I have just negative 36 of the sine of 6x. All right, so now on top, we're going to put zeros above pi over 9, 4 pi over 9, and 2 pi over 9. All right, so I have those. All right, on bottom, we're going to put a 0 below pi over 6, pi over 3, and then of course at the end points, pi over 2 and 0. All right, and so now I need to do my sign analysis. All right, so now to the left of pi over 9, how about 0? So if we plug in, we get 3 plus 6 times cosine of 0. Cosine of 0 is 1, so 3 plus 6, that's positive. All right, next, in between pi over 9 and 2 pi over 9. Okay, how about pi over 6? So 6 times pi over 6, that's just pi. So cosine of pi is negative 1. So 3 plus 6 times negative 1, that would be negative. All right, in between 2 pi over 9 and 4 pi over 9, how about pi over 3? All right, and so 6 times pi over 3, that would be 2 pi. So cosine of 2 pi is positive 1. So 3 plus 6 times positive 1 is positive. All right, and then to the right here, how about pi over 2? 6 times pi over 2, that would be 3 pi. Cosine of 3 pi is negative 1. 3 plus 6 times negative 1 is negative, right? And so right now, we know the values of the first derivative. So we can answer when is f increasing, decreasing, local extreme values, right? So you can say f is increasing on what interval? Well, whenever it's positive. So that would be from 0 to pi over 9, and then from 2 pi over 9 to 4 pi over 9. And that's it, right? So that's increasing. All right, f is decreasing on the interval, well, whenever it's negative. So that would be pi over 9 to 2 pi over 9, and then from 4 pi over 9 to pi over 2. All right, so that's increasing, decreasing. All right, now, what about what's going on at pi over 9? Well, the derivative changes from positive to negative, so that's going to be a local max. At 2 pi over 9, derivative changes from negative to positive, so that's going to be a local minimum. And then at 4 pi over 9, derivative changes from positive to negative, so it's going to be a local max. So you can say local max at x equals, all right, that would be at pi over 9 and at 4 pi over 9. All right, and then local minimum at x equals, all right, and that would be at 2 pi over 9. All right, so that's the first part. Now, the second part, now we have to examine the second derivative. All right, so now I'm going to do my sign analysis below here. All right, so now sign analysis below. So now in between 0 and pi over 6. Well, how about pi over 9? So 6 times pi over 9, 6/9 reduces to 2/3. So sine of 2 pi over 3, right? So sine of 2 pi over 3 is positive, right? Because it's in quadrant 2, but then times a negative, so this would be a negative number, right? All right, in between pi over 6 and pi over 3, so how about 2 pi over 9? So 6 times 2 pi over 9, that would be 12 pi over 9, or 12 pi over 9 reduces to 4/3. So sine of 4 pi over 3, that's negative because it's in quadrant 3. So times a negative 36 is a positive. So we get positives here. All right, and then in between pi over 3 and pi over 2, so how about 4 pi over 9? So 6 times 4 pi over 9. All right, so that would be 24/9, or that would be 8 pi over 3. So sine of 8 pi over 3. So 6 pi over 3 is the same as 0. So 8 pi over 3 is the same as 2 pi over 3. And so that would be a positive number times the negative 36. So we get a negative there. All right. Whole lot of unit circle trig and stuff going on there. All right. And so now we know when f prime is positive and negative. And so now we can answer concave up, concave down. All right. So we know concave up is when f prime is positive. So, sorry, f double prime is positive. So f is concave down on the interval, well, whenever this is negative, so from 0 to pi over 6, and then from pi over 3 to pi over 2. All right, f is concave up on the interval. All right, so then whenever this is positive, so pi over 6 to pi over 3. All right. Now, you also know points of inflection. Remember, points of inflection occur when the second derivative changes sign. All right. And so you would be able to state, okay, that a point of inflection occur at x equals pi over 6 and pi over 3, because that is where the second derivative changes signs. All right, now the last step is to sketch a graph. All right, and so what we need to do is we need to match up the signs of the first and second derivative. So we have a positive and negative here, we have a negative and negative, a negative and positive, a positive and positive, a positive and negative, and a negative and negative. All right, so each curve. So first derivative positive, second derivative negative. First derivative positive, second derivative negative means increasing but concave down. All right, so something like that. Let's draw it a little bit better. All right, so increasing and concave down. All right, next, negative and negative means decreasing and concave down. So those two should join at a local max, right? All right, next, negative and positive. So that would mean decreasing and concave up. So these two pieces should join at a point of inflection, right? All right, next, positive and positive. So increasing and concave up. And so that means these two pieces should join at a local minimum. Of course, they do. And then we have this positive and negative. So that means increasing and concave down. So those two pieces should join at a point of inflection. And then lastly, negative and negative. So decreasing and concave down. And those two pieces should join at a local max. All right. And so now what we want to do is we want to graph this. All right. So now we're graphing. All right. Now we don't know any y values, okay, yet, but we know we're going from 0 to pi over 2. All right. So we can get a y value just to kind of get a start. So I usually just like to start at 0. And so if I plug in 0, I get 3 times 0 plus the sine of 6 times 0. So that would be 0 plus the sine of 0. So that's 0. So we have a point at 0, 0, and that's where we're starting, right? Okay, and so we take this first curve here, right? And then we go to pi over 9, right? Where we go to the next part of the curve, right? Which goes down like that. Then we join at pi over 6 to the next part of the curve, which goes like that. Then we join at 2 pi, that's 2 pi over 9, where we join to this next part, which goes up like that. Okay, then we join at pi over 3 to the next part, which goes like this, and then our local max at 4 pi over 9, which then goes back to pi over 2. Now, the only point we actually know is 0, 0. All of these other points we don't know off the top of our head, but we could find them by plugging them into the original equation. But that would be our sketch of that function.